and yeah, my name is Anton. I work for JetBrains. I'm a developer advocate. That was correct. I talk about Kotlin to developers, and I talk to Kotlin developers from the name of the users, from other developers, like doing this duplex connection between the Kotlin creators and Kotlin consumers. And today I realized that well, it will be quite challenging for me to actually explain the basics. I had never done that. I was always, talking about what's new in Kotlin and or what's new in this exciting programming language and how you can use this particular feature, but I never was explaining to anybody from scratch, like from basics. And I don't know your background, so if you can type in the chat, like, are you new to Kotlin? Is the first time you're seeing it? You have not used it? Please give me some hints, in the chat. I have it open, so it will give me some let's say information, and I probably can change the content like on the fly, depending how it goes and depending how you understand while I'm speaking. If you have any questions, like, you gonna type it in the chat, but probably I will not see it because it's so many of you. And then maybe if you're really impassioned, or like, it's a good thing to actually break me and ask the question right away before I go to something else, and then you forget the question, and you probably will not get the answer, and you will not get this valuable knowledge. And let me see what I can do. So we're gonna have three parts in the plan. I have three parts. I wanted to explain the basics, like give the introduction to the language, which I said will be quite challenging for me because I have never done that. Then I will talk a little bit more about this like more advanced concepts of the language, why it's designed this way, why some features play nicely together. You can try some of the things as I talk. Like if you have IntelliJ installed, then you have Kotlin already bundled in the IDE, and you don't have to install anything. So you can give it a try. But actually, we have tools for trying the features in web-based environment as well. I will show you how to do that. So you wouldn't have to install anything if you don't have it installed yet on your machine. And if you want to try something, it's quite easy to go to the web page, write some snippet of code, and try it out how it works. And at the very end, I will give a brief overview of the ecosystem as well. What kind of tools we have? What kind of frameworks and libraries do we have by the team and in the community as a whole? Because the language became quite popular, and a lot of developers are using it. And of course, they are creating their own tools, their own libraries, frameworks, and so on. Another challenge that I have today is to speak through the whole, time, like 3 hours. Maybe we'll make little breaks, but it will make my life much easier if, let's say, Alexander and Sergey will ask questions, proactively, or interrupt me, or we could have some interaction. So Sergey and Alexander, don't go away.
Sure,
Maybe you can.
we're here for the whole session, so don't worry.
Perfect. So it will make it more fun, because otherwise it's just my talking head, and it will make more fun for the others to actually, grasp the information, process it, and not get too sleepy because of my voice. I know I'm boring. Okay, let me try to share the screen. I'm trying to share the screen, and maybe it's showing.
Yes, it's quite fine.
All right, perfect. So let's get to the introduction. Yeah, I told you I'm Anton. I work for JetBrains. I live in Tallinn, Estonia. So if you don't know this small country, It's on the north of Europe, basically, in the Baltics, not too far away from St. Petersburg, but it's so small, like people generally don't know it. If you need to ask any questions after the session and you need a way to find me, I'm on Twitter. So Anton Arhipov is my handle, and you can always find me there and ask questions there. So don't hesitate. And let me give a very brief history in one slide. Basically, Kotlin was announced a little bit more than 10 years ago at JVM Language Summit. There is a small conference like that with this name, JVM Language Summit, where people come together and talk about the Java programming language development, JVM, and other alternative JVM languages as well. So in 2011, it was a year when a lot of JVM languages were announced, like either new or those that were upcoming, or those that were in development for some time but wasn't announced. So at that time, Java, the language, wasn't developing too fast, and it was the acquisition of Sun Microsystems by Oracle. So Java development was stagnating for a bit, and we were waiting for the new features desperately. And community wasn't happy with the Java programming language development speed. They wanted more features quicker. So a lot of companies started their own projects, with the aim of creating a better language than Java. And Kotlin appeared with this wave of the new programming languages for the JVM. So in 2011, it was announced for the first time. It was in develop. By that time, it was in development already for a couple, let's say, about maybe half a year or so. So in the beginning or in the end of 2010, the project started. It got some shape where it was good enough to show it to the public, basically saying that, hey, we are working on it. At that time, I wasn't part of JetBrains, and but I kind of happened to be in the same place when it wasn't when it has been announced. So it was quite interesting. At that time, I was pretty interested in different languages, but I thought that Java is the #1 language for JVM, and the other languages are for research and development. Like they create, explore the ideas, and then those ideas would flow back to Java. But it didn't really work out this way. And the irony is, now 10 years later, I'm a developer advocate of Kotlin. Later, we started adding more, let's say, backends. We call them backends for generating not only JVM bytecode, but some other target formats. I call them formats, particularly JavaScript, and of course native platforms later. And at that time, we already started experimenting with Android as well. Because Android is genuinely, it was built with Java tooling in mind, and although the runtime itself is not a JVM, and it wasn't a JVM at Android, but all the tooling around it and the language that was used to create programs, to create apps for Android, was Java. So it was kind of inevitable, or it was obvious, to try running Kotlin produced code on Android as well. But it wasn't really official Android language at that time. So in 2014, we've got Kotlin 1.0. Basically, it was
actually it was 2016.
16. Okay.
Yeah, no, not 14.
I gotta fix it. But it felt to me like the gap between 2013 and 16 is too much, so I decided to change it. All right, so I remembered incorrectly. All right, later I will send the corrected versions of version of the slides. So In 2016, after the release, we added some more features to the language. Of course, every release added something to the language, but I think notable features are the addition of coroutines in 2016 in Kotlin 1.1. Those were in the experimental state, and you obviously, not obviously, but most likely you don't know yet what the coroutines are, and that's a kind of a feature for asynchronous programming when you can do, let's say, non-blocking invocations within the program execution. And for that, in most languages is responsible the runtime. In Kotlin, it's kind of a feature of the language with minimal support and with the implementation in the standard library, not even in the standard library, but in a core library that is provided with the distribution. In 2017, we started experimenting with native platforms, so you could compile Kotlin to machine code without intermediate JVM bytecode by using LLVM project. So I think at this time we have about 20 different platforms supported as a target. So you could generate code for Linux, Windows, ARM, whatever. Later, we added some more interesting features to the language. Now, in 2018, it became possible to create multi-platform projects with the support of the language. Like there are a couple of keywords that enable, similar concepts that you have in C or some other languages. Like multi-platform abilities in Kotlin is not unique. Like it's not something unique. It's not something Kotlin invented. And generally, Kotlin is not inventing things generally, but reusing something from other languages. And if you are familiar with the other languages like Python or C# or besides Java, like something else, you will see some similarities. And that's, for real. There is even a talk by Andrei Breslav, who was, it's called Standing on the Shoulders of Giants. So he explains what features of Kotlin came from which language. So in 2018, we've got this asynchronous, feature of coroutines released in Kotlin 1.3, and shortly after, it was a very nice event called Google I/O, where Google announced that Kotlin is going to be the main programming language for Android. And after that, basically, the adoption of Kotlin skyrocketed, especially, of course, in Android development. But now it's increasing in other areas as well. At this point, I think a couple of months ago, we've got the information that about 80% of Play Market applications are implemented using Kotlin. And currently, we are at version 1.620. The release is coming soonish, let's say within a month. The plan is to release the new version. Currently, the stable version is 1.610. And last year, we started experimenting with the new backend targeting WebAssembly. It's kind of an experiment for the future, because WebAssembly is an exciting runtime, but it's not very widely adopted yet. So we hope that we are not missing the train here, and we want to do some work upfront before other languages do. Okay, just a general, very simplified description of Kotlin. It's a general purpose language. It wasn't tailored for, say, building Android application. It's just worked out this way. It's modern. We would like to classify it as a modern, meaning that the syntax is something that is attributed to modern programming languages, and I think there are, let's say, about a handful of different languages that we can. I personally would attribute as modern, like TypeScript, Swift, Kotlin, Rust, and maybe C# is still a modern language because it incorporates all those ideas as well. Well, maybe someone else can tell, like, add to this list. It's object oriented. It follows some object oriented paradigms, and like not some, but quite exhaustively, I would say. It supports functional programming to some extent. It's not as functional as Haskell, for instance, but it borrows the concepts, and it's pretty pragmatic. It's statically typed, and sometimes when people come from other languages where types are, let's say, written explicitly out, and they see Kotlin for the first time, they think it's dynamically typed, but it's not. It's using modern compiler techniques like type inference, and therefore it gives you the impression that it's dynamically typed, but actually the compiler is able to check the program if the types are correct or not. Multi-platform, I mentioned already, like in the history slide, that it's aiming to target different platforms, not only the JVM, but also like the WebAssembly native platforms, and who knows whatever runtime comes next. And it's also asynchronous, which is a good feature of the language. And well, this capability is actually present in different languages, either as a library or a language feature or a runtime feature. But this is something we should mention when we talk about Kotlin. So if you go to the web page today, you will see that, well, it's a modern programming language that makes developers happier. Actually, yes. If we peek into the results of Stack Overflow, questionnaire or survey that is published. Let me check the chat. Yep. So, like, if we check the results of the Stack Overflow survey, Kotlin is one of those languages that are beloved by the community, and generally people want to program in Kotlin. And but it doesn't tell you much. The page doesn't tell you about the language yet, right? So below we can see a few squares. Those are the squares for the, let's say, for the domains, for the technical domains. Whether I want to use this language for Android development, for server-side development, maybe I want to develop web pages with, interaction, or there is like one area where we exercise the multi-platform capabilities of Kotlin. That's currently mobile development, where we can share the code between Android and iOS platforms. Those are very different technical platforms, and Kotlin can gives you the tools to share the code between the different targets. So you can write, let's say, a library, and then reuse this library in different applications, targeting Android and iOS. Below there are a couple of links, multi-platform for other platforms, because mobile is not the only scenario where this multi-platform capabilities can be used. For instance, we have a product called Space, and it's a service for developers to track their projects, and it has multiple clients and it has multiple components. So it has backend, which is written in Kotlin. It's a web application, and then since it's a web application, it obviously has a UI, and the UI is very different. It has a web interface, it has a desktop, although it's implemented with Electron, so it's basically a web page. But then it also has Android and iOS clients. So this team is making basically testing out different scenarios for the multi-platform whether or not the code could be shared between different targets, and it seems to be working fine because the product is alive and developing. And the last part, probably Alexander will talk about it much more. I just want to mention it. Data science. There's a bunch of different libraries and tools for working with what, Alexander?
With data. any kind of data, actually.
Doing science with data, yes, because this is a large area, and there are different segments in this area, like where you want to do math with the data. Either you want to pump the big data from one point to another. So there are different disciplines, and I'm not going to dive into that much. I'm actually going to concentrate on the second square of my specialty is the second square at the picture, the server side. I'm not going to teach you right away about developing the web applications. Maybe we are going to get to there, but I'm mostly going to talk about the language itself. That was a not so short introduction, but since we're talking about the language, and I already started comparing it to Java, since the roots are in Java for Kotlin, and it was developed at first as a better Java and as an alternative JVM language. In the documentation, we do have a page, and if you're familiar with Java, it makes sense to check this out, to check this page, to compare, like what are the issues of Java that have been addressed in Kotlin, what's improved compared to Java. Especially the authors were using this effective Java book where the anti-patterns and best practices were described, I think in 2005, even like long ago. So they tried to make the language that would improve on top of the mistakes that were introduced in Java in the design of the language, and add some features that were either not present or like make a more modern feel of the language. And the list is quite long. We are not going to probably walk all the features, and I don't even have them all in my head, but I will try to explain some of the things. So let's dive in the basics. Basically, every program should start somehow, and that's the main function and the hello world, right? And that's the entry point for the application. And if you're familiar with Java, it feels like very minimal compared to what we have in Java. We have to create a class in Java, then we have to create public static void main function, and then it would be the entry point. Here we have just fun main, and even the arguments list is actually optional. We can just start with main function. And oh, by the way, like let's switch to the web page, and I will show you. If you want to try something while I'm speaking, there is a page called playkotlinlang.org. I'm gonna paste it into the chat. Oh yeah,
I've done it.
Alexander already, yep, did it. So if you want to try something, you can do it like this. Just type print lan hello. Even auto-completion works sometimes, and run. Hello. So it runs and it compiles and it runs. So and this is pretty useful. You can try with different versions of the language. Probably not too useful to you for you this time, but then you can actually try with different targets as well here. And if you need to give some arguments, let's say args array of strings, and then run this application, let's say like this, args 0. I hope I am not making too many mistakes. Yeah, so it prints out. I will explain the syntax a little bit later. So you can, you know, try different things here. You can get examples from here. You can get to the docs. So we have links, and you can share the code with your peers as well. So this is a very useful application for you to experiment, to play with the language. That's why we call it a playground, and you know, hence the main name here. All right. So we have the entry point, and you immediately see that we have a top level function there. So we don't have a class, we have just a top level function. This is something that is not obvious for Java developers when they structure the programs, because we are using, especially if you have been programming in Java for a long time, people get used to, you know, creating classes and interfaces and working with them, and this is something that is, you know, not too obvious for them, that you can just program in functions. For other programmers that come from Python or any other language that has top level functions, this is an obvious thing. This is familiar, and they know how to work with them. But for Java developers, the very first impact that it has, it's the structuring of the application. When you realize that you can actually write the whole application just in functions, you start structuring it a little bit differently, and then you realize that you write less code, then you don't create a class per file or file per class, and then you basically start grouping your functionality in the applications into files, and then you realize that you start structuring the application differently. So top level functions have the impact on how we are structuring the application. There is a question in the chat: could you recommend an interesting and detailed book article about coroutines? There is a good documentation about coroutines, although it's you have to put some effort into reading it. By the way, I just recently got a book, which is created by one of the community members, and there is a chapter about coroutines. So this Kotlin design patterns and best practices. This is where you get some information, like in the book about coroutines. I think the second edition of Kotlin in Action book is going to have a chapter on coroutines as well. But I would recommend listening the talks by Roman Yelizarov and reading his blog about coroutines. This is where you get the most, you know, information and most interesting, insightful articles about the subject. Where to find this book? As I mentioned the name, you can find it on Amazon. So any Amazon website sells this book, and it's by Pact Publishing. So on the editor's website you can find it as well. But generally, just Google for the title. Let's go further. Functions. We started to talk about functions, and obviously functions have arguments, and this is the syntax how we declare them. We have a parameter list. We declare the arguments in a way that we have a name, colon, and the type, and then it's a list. And then the return type is specified after the parameters list. This is very different. This is like vice versa from what you have in Java, right? You would otherwise write the return type of the function, the function name, then the parameters list would be declared in a way that you have a type first and then a variable after that. That's vice versa in Kotlin, but you can find similarities in other languages like Scala or even Pascal, right? This specific function is a very short one. There is just one statement, so we can actually. Oh, I didn't write out the alternative for this one, but I will do that immediately in the IDE. So if we have it like this, we can actually do some transformations, like transform it to the expression body syntax, just have a equals mark and have expression after that. That's another way to specify it. And even we can amend the return type. In that case, the return type of the function will be derived from the type of the expression. That's called type inference. And we are going to talk about that a little bit later in more details. Okay, so functions. Then we have variable declarations. It's a little bit different from Java as well. So generally, if you are getting used to Kotlin, you are not using types that much. You just specify the value after the equals assignment operation, and the type is inferred. But sometimes you want to specify the type if you want to declare or assign the value a little bit later after the declaration. So that's another option. Like this, for instance, we have a couple of variables where the first assignment is actually resulting in a double, and the other one, x, is actually an integer. And let's compare to Java. So for instance, if we explicitly declare the types for Kotlin, it looks like this. We have a variable name on the left and then the type on the right, optionally, because actually we can do it like this. We can use type inference, and the type will be derived from the right hand side immediately at the compilation time. It doesn't mean that the variable type is going to change. No, it's going to be calculated once and will stay like that. So if you declare the variable for the first time and you assign the value to it, the compiler will calculate the type, and it will not let you to assign any other value of any other type to that variable later on. So for instance, if we declared s and we assigned a string to that, hello, in the next line we could not assign a different type value to this variable. For instance, let me show you how it looks. I will increase the font. Hello, s, and I'm going to assign an integer. Actually, I'm not able to do that because it's a constant. Val is a constant. We cannot reassign the value, and var is a variable where we can reassign the value. So for instance, if we declare it as a variable and we want to reassign the value, we can do that with the string, but we cannot do that with an integer. So it will be a compilation error, and statically typed languages are good for this thing, that hey, the compiler will check the possible errors for you. There is a comment that Kotlin is similar to Golang. Well, maybe it's the first impression because we have those fun and func in Go and then val in Kotlin, but it's probably the end of similarities. Those are two very different languages. Kotlin is very expressive and has a very strong type system. Go language has a very minimal type system, basically none. Okay, let's go further. Oh, I messed up with the slides, so I wanted to show you this, and we can remove the type inference that I already told you. Functions can actually return no value, and for no value type we have unit. So you can indicate that this function does not return any value, actually returns a unit, but it's optional. So whenever the function itself, the body of the function, does not return anything and we have not declared anything, then basically we can amend this type declaration in the function signature. There is another trick that we can use in the when declaring the functions. For instance, we want some function that returns a string. Okay, that returns some value. Let's say it's a string, but we don't know how to implement it. And then there is a trick that we use quite often. We specify to do in the to do function call in the function implementation. If we don't do that, it will be a compilation error, because the function actually, you know, we just declared that this function should return a string, but we are not returning anything. We could actually return an empty string, but maybe we are going to forget about it, and it will be a mistakes that leaking in our code. So to prevent that, to actually make a bookmark for ourselves that, hey, we need to fix something, and we shouldn't miss it when we execute the program. We have a function called to do that comes from the standard library, but it's a real function. But our foo function needs some return value. How come our function does not return anything yet? We just have the to do function invocation in there. That's a good marker instead of a comment. So it's a real code, but the compilation succeeds. So if we go and look into the declaration of to do function, it actually has nothing as a return type. That's a very interesting one. So nothing is basically a return type of the function that never returns. So here we say that to the compiler, hey, we have this invocation, but it never returns. So it doesn't matter if we return anything from here or not. So data flow analysis will check, hey, this full function will never return. It will be stuck in the middle. So that will be kind of like if we execute it, it will be actually a runtime exception, I think. It's gonna take a while to compile. Anyways, yeah. So it tells me not implemented. The operation is not implemented. Please, fix it. And that's a marker for us. The test, if we gonna run the tests, it's not going to, succeed. So we have to fix it. And in to-do list, I think we have this function to fix stuff. So that's automatically is going into bookmarks. It's a sign for us to improve everything. And as I said, it was possible thanks to this nothing return type. That's an interesting feature of the language type system. Let's go back to the slides. Besides normal functions in Kotlin, we are able to create functions for the existing type. So whenever we cannot extend the existing type, and that's for the reason, when we have no control over the code that was written, maybe not by us, and then for the reason how the open object-oriented design is done in Kotlin, and also for the reason that we can scope the extensions, within the specific scope of the program, let's say either within a class or within a function or within a file or within a package, or like wherever we decide. So in this example here, we have a function that, it's a single statement. We have a string, and then we run the application, and it is going to say, hello world. How is this possible? String doesn't have a function called say. And where is it coming from? And it's coming from our definition. We just created the extension for this specific case. We want to have this say function that is going to print out the receiver itself. So whatever object we create, a string or whatever else, in this case, we are creating the extension for the string. then inside the body of this function, the implicit receiver, this is going to refer to the string itself. So let's try that. Let's try running it. I'm going to just copy and paste like this. So if I'm going to run it, it's going to say hello world. And whatever I'm trying to do with this in this part is going to refer to string. So all the members, I have access to all the members of the string class, and that specific particular instance of that string. So hello world, for instance, I want to print out a length. So I have length of that string right here. I have access to everything. Okay, so that's an interesting feature. We are going to see a bit later how we can apply that in more specific cases. Functions, since we have top level functions, they can be used as parameters as well. And for that, we need to declare the signature of the function appropriately. So in this specific example here, we have function called process, this one. I'm not sure if you are seeing my mouse cursor, but I'm going to pretend you do. Can you confirm? Yeah, you see, perfect. So we have this process function, and it takes another function as a parameter. And the way to declare that it takes another function is to declare it as a function type. The function type means that on the left-hand side from the arrow, we declare the types of arguments that this functional type takes as parameters and the return type of the function. So in this case, this process function is going to take any function as a parameter that takes string as a parameter itself and returns nothing. And in Kotlin, we can express it as a lambda expression like this. So this parameter process function invocation takes a lambda that takes a string, and the compiler calculates that it should be a string because we declared it in the function signature. So this is an example of type inference here. And then the return type of println function is unit. It doesn't return a value, so we have a match here. So the compilation should succeed. So let's copy this code into my IDE like this. Oops, something is wrong. Maybe the copy and paste did not work really well. Just a second. Let me try another time. Yep, this is something strange. Yeah. Now it works. And if you run it like this, we get hello world again. So once again, what is happening here? We declared the process function. We declared that this function takes a functional parameter as an argument, and this functional parameter should have string as an input, and does not have a return value. So it returns a unit, and then the compiler matches that this should be a string. So there will be a conversion. We can declare it as a string as well, but this declaration here, this type declaration, is not for the compiler to actually match to match the signature with the invocation, but rather for this lambda expression for the compiler to check the lambda expression that this s variable, the input variable, is a string and calculate it appropriately here, because otherwise we could just, you know, remove this function, and now we know that you know, this variable is a string. We expect that. All right. Are there any questions regarding that? Operation is the function name or a keyword? No, it's not a function name or a keyword. It's rather a variable name. So we can rename it, you know, like this. So this operation that we have declared as a variable name, as an input, you know, input name, basically we are just working with that further on within this process function implementation. And since it's a functional type, we can invoke it as a function. That is why we are, you know, writing this operation here with the parameter like this. We are supplying the parameter.
You can demonstrate it clearer by just calling invoke on this. I think it will be clear that it is a function.
Yeah, we can do it like this: invoke and then supply the name. Right, so it's a functional type. We can invoke it, and this syntax is just a shorthand. Otherwise, the compiler will do exactly as Alexander said. It will desugar this call into this invocation. Okay, further on. So we already talked about lambda expressions. They can be used not just parameters or like functions. We can actually calculate a type of a lambda expression. So if you declare a field or a variable within our program, we can give it a functional type and then assign a lambda to it. And of course, type inference works exactly kind of the same way. We can just declare this variable or a field and assign it, you know, a lambda expression, and then compiler will derive the type. Functional types have this tendency of getting quite heavyweight when you write it out. Like you may have many parameters and then this arrow and then the return type square. So it's a bulky construct. So sometimes for increasing the readability of the program, it makes sense to create an alias for your you know, functional type, like in this example here. And then we can actually, you know, use this type in function declarations somewhere. So for instance, like this. Let me try to create an example for that. Strange why copy paste works this way. So for instance, we can declare it this function here slightly differently, and the operation will be of int adder. And then if you are using this function, like operation, like invoke, basically invoke, we should supply the two integers. The ID is actually telling me that, you know, I should supply two integers, 1 and 2, like this. Or yeah, we can actually invoke sum in the same way. Next, default values. Yeah, if you work with functions, it's sometimes, at least it's kind of an idiom in Java. When you have many different parameters, let's say you have 5 or more than one parameter to the function, and you have this use case that sometimes this parameter should be like the default somewhere, and it's an idiom to override the functions this way. We have like a function with a single parameter, and then we delegate the call to the other function, which is an overloaded one with a different list of parameters, but with the same name and the same return type. That's the rule. This is the scenario how we implement default values in Java, let's say, like the Java way, but it's called the Kotlin syntax. However, to avoid, creating long lists of overloaded functions, we can save some code and assign a default value right in the signature of the function. This way we can declare it once, and then in the place of invocation, we can just supply one parameter instead of two. It's a very simplified example, but imagine you have different set of parameters. You have 5, let's say. But if you have a longer list of parameters, like in this case, for instance, we have a class that declares like a constructor. This is the syntax for constructor. We have 5 parameters, all of them have default values, and then you want to invoke or create an instance of this figure, but overwrite something. You don't want a black cube, but you would like to have something else. You would like to have a red cube, for instance. So you want to supply just red and give a different description. So in this case, this kind of invocation will produce a compilation error. I have messed up the slides a little bit. Yeah, so this one will produce a compilation error, but why? Because in this case, the compiler doesn't know to which position you're assigning this parameter. Like it's generally not possible to to derive. In this specific case, it would be possible because we have different types, but it would increase complexity of the language. Like it's not consistent in that case, because imagine if we had all the parameters with the same type, like all the strings or all the integers, then we don't know, then the compiler doesn't know which of the values you want to override, like reassign. And in this case, it's possible to not just write out all the parameters. You can give the names of the parameters. You can specify the names of the parameters, which parameter you want to reassign. So in this case, we are reassigning the color and the description. And this also increases the readability of the code, because in many cases, of course, the IDE, the editor itself, if let's say we try this example right here, what will happen like if we work with the editor? Color is, let it be an enum class, maybe right here, like this, and then we have black and red. That's an enumeration, so there is a way to specify basically constants within one type. So in this case, if you just haven't met any enums before, so and then main, if we put it into main, so if we had it like this, let's say 1 1 1 2 3, color red, that would be the full invocation, right? Or whatever, or red is more appropriate in this case. So the ID is telling us, right? ID is smart enough to tell us that, hey, this is the width that you are specifying here. Maybe it could be this way, right? Maybe you specified 1 on the second position or 1 in the third position, but still the semantics of the field is constant. It stays on the same position. But if you open this code in the, let's say, web editor or like web viewer, then generally they are not that smart. They don't have the smartness to show you the hints, like the information about the variables and extra extra descriptions for them, then you lose this readability that you have in the editor. But if you use the named parameters, it's not going to disappear anywhere. And even if you open it in the web viewer, you're still going to be able to read it, and hence this this kind of syntax is very welcoming for your teammates when they will read your code. Let's say not only in the IDE, maybe even just opening a text file without the smartness of the IDE. Any questions? Color is another class here. Yes, it was another class. Okay, Alexander is doing a great job answering the questions instead of me. Let's see, what do we have else in slides? So I wanted to say, with that, I wanted to say that default parameters actually diminish the need for overloading in most of the cases when you need to supply default values. So just this small language feature would decrease the amount of code that is written by the developers by a good percentage. And then named parameters, the ability to specify which value you actually are supplying to the invocation, either of the constructor or of the function, is a very good tool, because then it makes the usability of this feature much nicer. Like Kotlin features operator overloading, which is implemented through functions, and it's a convention.
Sorry, Anton, there is a recurring question, and I think the one you should ask, because the difference between val and var people do not understand. And
okay,
I answered that it is a read-only, but they do not understand the difference between constant and read-only.
Okay,
which is
let's do that. That's a very good question. Thank you. Oh, let me. Okay, sorry for that. So like var stands for variable. So if we declare something as a variable, let's say we explicitly type out it's going to be an integer, right? And we can reassign this value. When is it happening? Let's say we are writing some logic, like checking for something, like let's say args array string. So we have parameters there, and we have some default value and declared in our code. That's the logic we write. And by some logic, we want to assign a value to this variable depending on some condition. Let's say if the args size, it should be length, damn it, it should be count actually. Yeah, count is the common function. If the length or the number of elements in the array is greater than 10, then let's assign some value to a. Let's say it will be, I know 1,000. Or otherwise, a should be 500 or 501, whatever, like some other number. So in this case, you can clearly see the difference, that we are reassigning the value. The ID tells you that by rendering an underscore on this under this variable name. So basically, it's saying that this variable is a var through the var declaration, means that this value is mutable and can be reassigned, right? And if we declare it as a val, then the compiler will scream at us saying that you're trying to reassign a constant, like an immutable value. I'm not sure, like, was it clear to whoever asked the question? Please give me a note. If it's not clear, I will I will try to explain it once again.
And actually, in this case, you need val, not var. Actually, because you do not change it in the processes for people to think about. That you do not need a mutable variable in this case. And IDEA actually tries to say to you that it should be inlined. Yeah.
Well, like to put it this way, like why is it needed at all? Like maybe it's like the difference is clear, but why is it needed at all? The thing is, sometimes when you write a more complicated logic that you have to understand, it makes sense to create variables as not reassignable, you know, as vals. So it will force you writing a clearer code. And since it's so easy in Kotlin, just, you know, one character is the difference. And you develop this habit of declaring vals instead of vars, and we have features, as you have seen in the IDE, to help you with that, you know, notifying that you're actually creating a reassignable value. Then it kind of pushes you to, the Kotlin itself pushes you to create vals instead of vars. And then it changes the style, and the style is the kind of, it has the effect that it becomes a bit harder to make logical errors in the programs. It's a very basic explanation that I have in my head. To show it as an example, I probably would have to spend some time, and we don't really have that much. Okay. I started to talk about operator overloading, and it's possible to overload the operators, the plus, the minus, the whatever operators do we have, like multiplication. So we would have those operators not just for the basic values like 1, 2, 3, like integers or doubles, but also for the classes. So in this example here, I have a data class point. I'm going to explain what data classes are in a moment. And then I would like to have some logic for the operator unary minus. So I'm creating this operator function with the name, with the appropriate name, and those names are in the documentation. It's a limited list of those functions that you can create. And basically by the name, the compiler will figure out, hey, okay, this should be the operator. So if we say it's unary minus, then whenever we say minus point, it will be desugared into this function call, and it will kind of result in this function invocation. Let's try to play with that a little bit. I have seen the raised hand. Maybe someone wants to ask the question. Don't hesitate. So just interrupt me. The copy paste is somehow broken from the slides. Okay. So as you can see, this is a class, right? So we're gonna talk about this data part a bit later. So we create this unary minus function, or it could be unary plus as well, plus or just plus or something else. So there is a number of functions that we can override for any specific type, and then therefore create our own operators that work with this specific type. Okay. Let's go further with that. Expressions is a very interesting thing in Kotlin. Generally, if you have been programming in Java or maybe some other languages, generally we think of if, when, or try catch blocks. as something like structural in the code to just do logic like control flow. But in Kotlin and some other languages as well, those are those language constructs can be used as expressions. They return values. So by this language feature, this code that I have on the slide right now could be transformed into something like this. You see, it's much shorter. Let me go and show it in the ID. Where do I have it? Expressions. So in the beginning, I have this function, adjust speed. Just imagine I'm developing some game, right? I have a autopilot functionality like for the car, and then I have to automatically adjust or write logic that adjusts the driving speed, so depending on the weather conditions. So the ID actually tells me, I'm not sure if it's visible, but it shows me the underscore under the if expression, and in IntelliJ IDEA it means like a small hint for you that you can do something to simplify, or like to simplify this expression or this piece of code, or like to maybe it even potentially has a bug, or so it's not very idiomatic, let's say. We can improve it, right? So it's a hint for you to actually hit Alt Enter in the ID, and if we press Alt Enter, then it tells me that I can lift the assignment out of the if expression, of the if block, right? So currently it's used as a statement, not as an expression, because like we are not assigning or returning a value out of the if. Otherwise we could just create some variable and actually write an assignment operation. It will be a valid syntax, but then it will be a question, what are we returning here? So the ID is actually helping us with this automatic transformations in order not to lose the logic, like so we would not mess up the program. So the automatic refactoring takes place. So if I hit Alt Enter and choose this option, like lift assignment out of if, it will result in this piece of code. So it takes the assignment. We previously had this assignment like this result, and instead of reassigning the value within the if expression, we are returning the value from the if expression. And now, since we just declared on the first line the new variable, and we are creating the assignment on the next statement, basically, we can just merge them together. So we can hit Alt Enter and join the declaration and assignment like this. Since it's just a single statement here, and we are returning it, and actually if can return a value, then we can remove the explicit type. Here we can probably inline the variable like this. Yes, we can just return the result of the if expression. Then we can simplify using the expression body syntax, like the assignment operator we have seen before, right? We have seen this syntax before in the slides when we learned about the functions. So it goes further, and we have learned before that we can amend specifying the return type from the functions, and it will be calculated from the right hand side of the expression, basically. So we remove the explicit type here, and we can even remove the braces from if like this. No, maybe not like this, but a little bit differently. Let's say remove braces from all if statements, so it becomes like a very small expression. So we started from this and we ended up with just one liner. So at this point it feels like, oh, I simplified it for quite a bit, so it's so nice. And it's concise, and it really is. But is it readable? It kind of depends. So you have to be careful about this kind of approach. Why? Because if we cover the right-hand side of this function, so we cover the body, and if you look at the signature of the function, we cannot tell what is the return type. And that's crucial for many applications, like especially for the developers working on complex projects. Like you're observing the code and you're reading this function signature. So to make sense of it, you need some information about it. You need the types of the parameters, and you need to know, in many cases, you need to know the return type. But looking at this declaration, you couldn't tell without actually reading the implementation of the function. And let me show you the other. Oh yeah. So if we are working with this kind of code, the general rule is that if this function is a part of public API, let's say you are creating some library for the others to use. If this function is part of public API, then you should declare the type. And there are compiler options even to enforce that. If the function is not private, then it should have a return type specified in the declaration. And if it's a private function, then it's fine, to amend the return type, because then we can use this type inference. So why is this important? Let me show you. So if I let me collapse this part of code, we don't need this at this time. So if I have it like this, and I ask the ID to please specify the return type explicitly for me. So let's put it back. Return type explicitly. It tells me, hey, this can be a drive and it can be any, and well, it's a valid choice for both, right? But generally, we want to be more specific, and I choose drive. But if it basically, this information comes from the compiler. So if I don't specify it, it will be the most specific one, so it will be drive. And I can, in my main function, I can declare a variable drive, let's say, and I can adjust speed with rainy. Okay, and it's a drive. If I ask the ID to specify the type explicitly, it will be drive. So everything is good. But if let's say for some reason I was working in the code and I don't know about the usages of this function, I was working with the code and I was changing it somehow. I was doing refactoring. I got new requirements from somewhere, and I want to change it. And let's say I accidentally, or just by by the logic that I've got, I changed something in the logic of this function, like this. Suddenly I break the type inference. So I changed, like not really breaking the type inference, I'm changing the return type of the function. Now if I ask it to if I ask the ID to return, specify the return type, it will be any. There will be no option for drive class or for the drive type in the return options, and I will break all the clients that are using my code. So if it was a library, let's say this adjust speed is part of the library, right? You have written a code that is part of public API of library, or even a package within the same application. And then I have some code in some other place, this code that uses this function and invokes it, I will break it, right? And it's especially bad if you are developing this kind of public library, which is used by some other developers. They would get the new version of the library where you have changed the signature, like without knowing that you actually changed it, and it will just break their code. It will be all fine in your library, but it will break your user's code. That's not good. So if I had had it specified previously, and I was changing it, from safe to whatever it was, calm. So if I was changing it and the type was specified, let's say I changed this return value here, then it's a compilation error. Then I wouldn't, the compiler would prevent me from breaking other people's code. So this I wouldn't kind of destroy the world instead of I would destroy my code instead of destroying the world. Okay, any questions in the chat? Yeah, library code, that's what I said. There is a compiler option. Okay, good. All right, so we talked about expressions. It's not only if that can be used this way, there is also try. So instead of just invoking a try block, we can use it as a try expression. For instance, we can, no, this function here. So if our logic was like this, let's say we are doing this try block here and catching an exception, and then depending on the logic here, this control flow should produce some values like safe or calm, something like this. Then we can actually type return, and since try can return some value, we can use it as a return, statement with return statement, and obviously we can use it with the expression body syntax the same way. And the other block of code, like the other statement that we have in Kotlin, is pretty powerful. When statement. So instead of if, we can actually use when, I think. Yeah, we can replace it with when. When we have just two options or like one condition to check, then if statement works great. And but if we start getting more conditions, then either we transform our code into nested if blocks, which is not really nice and readable. Instead, we could use when as an expression or as a statement, and then use different conditions, like declare those different conditions in here. What is really nice about when statement is that when you use the subject, which is of type of, like, not really type, but either it's a sealed class like here, or enumeration, or a Boolean type, then when expression has this property of the compiler, the compiler can check various options if all options are covered within the logic here. So let me demonstrate that, or it will be clearer. So if we are checking the weather, and weather has two options right now, and if we specify just a single one, then we are checking one option, but we are not checking the rest. Maybe we have more options here, like something like windy, clear, something else, right? Then this will be a compilation error if we did not cover all the options. So instead, the IDE would actually help us. Either we should add all the remaining branches, meaning we should specify all the options and check for them, or we should have an else branch, meaning that we check some of the options and then the rest. All right. So, like, for instance, remaining branches like this, or the else branch, and then do something with it, like print. Or we should actually specify something like calm. Interesting, it did it this way. Okay, good. Are there any questions yet? Connection issues. Well, the connection is sometimes unstable, so it might be an issue, but the connection might be unstable on my side, but also on your side. It depends. So sorry for that. If you miss something, then just re-ask again, and I will repeat. But otherwise, we have to rely on the connections the way they are. Okay, the when expression is what makes your code actually much safer. Why is it good? As I mentioned, this property that when expression has with the compiler check for checking for all the options works with sealed classes, enums, and booleans. Those are the types, or the types in Kotlin that can be exhaustively checked. So for sealed classes, if you have a weather, right, we have the implementations of the weather, like the derivates, in this case, rainy, sunny, windy, clear. And this is the exhaustive list. Nobody outside of my module can derive from weather. It's a sealed hierarchy. It's a closed hierarchy. And therefore, the compiler can do this exhaustive check. With enums, it's kind of the same way. When we declare the enum class, let's say color, as we had before, we enumerate, we declare the exhaustive list, right? So we give the compiler the list of options to check. So it cannot be extended the same way as the sealed hierarchy. And also the Boolean type, of course, it only has two types, the Boolean logic, right? The true or false. In this case, we don't have maybe or something like this within the Boolean type set. Then everything can be checked exhaustively. And recently, I think in 1.6, we also implemented it for statements. So if when statement is not returning a value, but returning, let's say we are returning calm here, return calm, so to be clearer. So if it's a statement and doesn't return a value, then we can also check exhaustively if all the options are covered. So even without returning a value, it should be a warning at least. So it tells me that I have to specify the branch. Currently it's a warning, but maybe, not even maybe, it's even a plan to make it a compilation error in 1.7, I think. I'm starting to run out of voice, so Alexander, if you can, please sometimes speak something to me so I can make
it's you are still here and we are still here. No new questions. I think people are trying to evaluate all those things you are talking about.
All right. How often do you use when expressions in your applications? Like, can you recall like the use of expressions in your program?
Everywhere. Actually, we switch to not using if in most cases, because if expression is just a specific case of when, and sometimes it looks more idiomatic to use when instead. And if you did not know, inside the compiler, it all changes to when expression. So there is no if inside Kotlin internals.
Perfect. And what I actually, if I remember correctly, even if we use when with something else than sealed classes, let's say with primitive types, there are no really primitive types, but with, let's say, integers, and if we use it integer as a subject, then we can actually check for values even like this.
Yes, there is no full-fledged pattern matching, and you can't check both values and ranges at the same time. But in general, yes, you can switch over. Yes, it's like switch, but there is a question in chat. It's a when like switch. It's like switch, but in switch you have to put break after each statement. In when, it's just one of those. In switch, it could be several at once.
I'm not even sure. Like, yeah, switch is more like in Java. In Kotlin, we don't have switch, and in Java now there is a different kind of switch. What you said, we have to put break after each statement. Now, for the specific type of switch in Java, we don't have to specify that. If we use switch with pattern matching, which was introduced in Java 17, then you don't have to specify the break, but it's kind of a special case.
Which is actually not a pattern matching, but the same thing the Kotlin does. It's like a little bit of marketing.
Yeah. All right, let's go further. So in Kotlin, we have a notion of ranges, meaning we have kind of intervals. So this is like an interesting feature where you can check whether a value falls into some range or into some interval. And this is like obvious or intuitive when we talk about numbers, right? So we check if x, which is 10, falls into an interval from 1 to y plus 1, right, which will be 10, and it means that x falls into the range, into that interval, and that's an interesting feature and quite useful in many cases. We will check that later. But ranges as a language feature goes further. If you have a range, if you have an interval, like let's say from 1 to 10, it's kind of intuitive wish that we could iterate over this range, and that's possible with loops. So we can use ranges in loops, and like this. So we specify the for cycle here, and we declare a cycle variable or loop variable x, and we say that, hey, this variable should loop over the range of integers from 1 to 5. And an obvious question would happen here, like would be raised here: what are the values? Kind of the intuitive answer would be like from 1 till 5. It means like 1, 2, 3, 4, 5. But we can actually change that as well. Something like this. We can say that the variable should iterate over this range with the step 2. So instead of if you recall how you implement such loops in other languages, like let's say for loop in C or for loop in Java, you would have to write some logic there. Hey, I want to increase by 2 or by 3. Or I somehow like play with the indices, play with the logic of indices. And here it's more like a declarative style. You declare that it should iterate over the range with these rules. Okay. And where is it useful?
Actually, for our Python people coming from Python, there is a slight problem here because it works only for integer numbers. It does not work, for example, for floating points. It's by design. There are a lot of thought put into it, but you can easily extend your ranges to be the floating point ranges to be iterable in your own project if you want.
Yes, I will show an example of a more complicated of something more complicated than just numbers with for any other classes. So if like basically if you declare your class as comparable, it's possible to implement ranges, and therefore you have this possibility to implement it for any other kinds like of classes, not just for numbers. You can implement it easily for floating point numbers, for just custom classes, for persons, even if the logic requires that, but it's not something very intuitive actually. Sorry, I will switch the slide theme now from dark to white and back, because I didn't have time to actually adjust the style, but the final version of the slides that I will send to you will be all the same style. So where is it applicable? Where ranges are applicable? For instance, checking if a character falls into some, into some list, into some range of the characters. This is how we would implement it otherwise if we didn't have ranges. The logic is quite technical. It's easy to read, right? So we can say, okay, this character that we take as an input should be, greater than a character, which is not very intuitive but technical enough. And if you have been at the computer science courses, you would understand that. But it's not very human readable still. But if we convert it to a range check, which is possible, we can say that this character should fall in the range of characters from A to Z, and that's a declaration, right? So it's more human readable. It's easier to read. It's easier to reason about. But underneath, it actually compiles to the same check. So there is no overhead, like compared to the previous implementation, which is also a valid one. When we start using those new abstractions provided by the language, still the compilation result is the same. So there is no overhead for the more high-level language features. And here is an example. Actually, it's a example from the documentation. You will find it there as well. You can, let's say we want to have a range of versions, right? And version is implemented as a pair of integers. We have a major version and we have this minor version, 1.5, 1.6 something, and maybe we have our own logic of how we implement the versions, and we model it as custom classes. And here the example shows like we have to implement the comparable interface for this version class, and we override this compare to function. And our logic in this compare to function basically declares how those versions should be ordered within the range, and therefore we can declare this as a range and use this range operator and use the in operator to check whether or not some specific version falls into the range. Let's see how it looks in the IDE. Okay, something is wrong here again with the reformatting didn't work really well. Main function should be, let it be full, so it will compile. So as you can see, it compiles nicely. We can check if what's the operator, and it will get us to the range 2, which was overridden. Oh no, it wasn't overridden. But anyways, like we can create ranges and use this in operator to check if a value falls into the range. I'm not sure if I'm able to iterate over it. Actually, I haven't tried. So let's say v in version range. Can I implement that? I need to implement.
No, you need to operator fun iterator.
Yeah,
in order
right,
to be
right. I need to implement another interface, but basically it will be kind of it will be
actually
possible.
you do not need to implement interface. You can add it as extension operator fun iterable, and it will be okay.
Yeah, well, I will not do that. Or let's try. Why not? It's interesting. Version iterate, right? Or iterator.
No, operator. You need to put operator modifier, yeah, and iterator, like in iterable, but not yeah, and the return iterable whatever. No, not iterable, but iterator. Yeah, you are correct.
Iterator.
Yeah.
Something like this.
And
so
you can put it to do, yeah.
If we implement that, then we are able to create a for loop over in version range. No? Something else should be done.
It should work. Version range, not version, but version range. You should wrong receiver. In operator fun, not version,
yeah.
but version range.
No.
Yes, closed range version. You should just copy it. Probably. Yeah, now should it work? It should work.
Yeah,
yes, it works.
Like this. So, like, if you need to implement something like this kind of, it's not even a language feature to implement. You kind of use other language features to implement or adjust the program somehow for your needs to make it more readable, to make it more pleasant to use. Okay. So this is about the ranges, loops. We have mentioned loops in many cases, but I think it's worth looking into it as well. So we said that we can create ranges, with integers. We can, but if we use it like this, let's say it's obvious, it feels nice, but let's say we are iterating over the arguments array. And we know that the array last index of the array is one number less than the size. Therefore, we declare it like this, and it's kind of tinkering with something, right? We were tinkering with indices that we iterate all over, and instead we can just use the special operators for creating this kind of things. So until actually creates a range from 0 to the number, to the size of the list or of the array, and that until, I think it's actually a function, an infix function. Let's say, sorry, we'll take this and transform it in the ID like this. What is happening? So args, array of strings. So as you can see, like in the slides, you don't see those hints here. In the slides, you see just, from 0 to arg size -1, but in the ID, you can see a couple of hints. It's for the reason that it wasn't obvious for many people. Either the indices that we specify for the range are inclusive or exclusive. In this case, it's inclusive, as we can see. And if we replace it with either until, it will be much more readable, or we can just convert it to indices. Then we don't have to specify this range and reason about it. We just declare that we want to iterate over all the elements or over all the positions in the array, and therefore indices is more preferable in this case. So and if we need to know, like if we iterate over indices, we basically iterate over the elements, but sometimes we need to know the position as well, like the index of the element itself, and then we have this function with index that actually returns a pair with index and it returns a pair, and then instead of using this args, we can just say that we want to use the element, right? So it gives us back two values, and we destructure them, and we are going to talk about destructuring in a moment. So if we go to the declaration of the function, It's decompiling. Maybe what's going on? Strange. Just a second. That's interesting. Okay, so it found. So we can see in the declaration that it's an extension function that returns, okay, it returns iterable, but this iterable, where is that? Okay, it's a little bit more complex than I thought I will explain. But anyways, some functions or some types in Kotlin can contain the component functions, and that's a prerequisite for you for the value to be destructured, and we're gonna get to that in a moment. So in this case, when there is an appropriate type, either it returns from a function or we declare it, it's possible to assign multiple values at the same time. It's also like a syntax sugar. We like in normal places where we declare the variables, we can do it just line by line. But in the places where we have, let's say, for loop, for instance, and like in this case, it's a really just like there is no other way around. It's just a super nice feature to shorten the declarations of loops, and you don't have to declare the variables before that, like this. So this one I showed you, we like last year we implemented this feature in the IDE to help people understanding ranges and work with them. So the IDE renders those small hints as math operators to for you to understand. During the third part of the presentation, ecosystem, tools, frameworks, libraries, are you going to talk about KMM? Well, I can mention it a little bit, but I didn't have actually plans for diving into KMM this time. It would be interesting to know what are you. It would be interesting to know what are you interested specifically like about KMM. What do you want to know? But this time I'm not planning to dive into KMM that much. Okay, destructuring. So how does it work? Remember we mentioned the data classes first. So we talk about data classes before destructuring. So if we declare a person, for instance, normally, if you're familiar with Java, if we declare a person as a class, then like the syntax would be something like this. Like it's a bit different, right? We would have to declare the first name as a string, then we declare the last name as a string. I'm writing the Java syntax right now, that's why we have the compilation errors. And then we have the constructor, public person, and then let's say the first name, the last name. We do assignments right here. I'm not going to write out the implementation. Then we would have to create the setters and getters for each field. Get first name. That's kind of a convention, right, for Java beans, and it has been followed by many frameworks, and it's kind of a convention that has been spread across the entire Java ecosystem. And the problem with this is that even for small classes, it gets quickly out of hand. Like we have to write a lot of code, and there is no compiler feature for this kind of things to generate it for you. So the only automation you have in the IDE is the IDE being able to create generate the code for you by the keystroke. You press the keystroke, and it generates getters and setters equals hash code for you, the constructor, and so on. And in Kotlin, we decided to make it a compiler feature, so we can declare it as a data class, and we just list the fields, whatever the fields should be. Of course, there are like some complex rules for corner cases, but very simple case here is that we just list the the fields or whatever properties that we have for this class. In this case, we have person and first name, last name, and then we annotate it with this data. Like I'm saying annotated because first it was the annotation data keyword was the annotation. Now it's a keyword. But anyways, it's a hint for the compiler that data class should have some extra code generated, and this extra code generated includes getters and setters, the constructor equals hash code, and some specific functions called component functions. So if we let's say we create an instance of person Anton Arhipov, then this instance will have component 1 and component 2 automatically generated functions. We only have 2 because we have only 2 fields, right? If we add another one, val age, let's say, and that's going to be an integer and let's say some number, then we would have 3 components, right? And depending on the position, we would have the function name generated. So why is this interesting? It's because we can actually on the next line create a declaration for all those 3 fields like this: name, last name. You see, I'm using like a little bit different names on purpose so that we wouldn't clash with the names of the data class fields. So first name, last name, and age like this. Age. It's not a convention. I'm just doing it on purpose, writing the capital letters because like it should be different, or not should be different. I want it to be different. And now I can just assign this property here, and it works in a way that print line actually for f name, for last name, for the age as well. Let's see if we run the application, we'll see Anton Arhipov 16, right? So this is where destructuring comes into the game, and thanks to those component functions, the destructuring works. So in fact, what the compiler does, instead of this invocation here, it retransforms it into something like this: p component 1, well, last name, p component 2, and obviously h p component 3. So, but this is like extra 3 lines, right? Extra 2 lines compared to the initial option or initial declaration. But using destructuring is very convenient, and as you have seen in the loops, it's even vital. Let's say it's like the alternative of declaring variables outside of the loop is not something you want to do. So this is how destructuring works, thanks to the generated functions. And you can actually create those functions for your classes. If, let's say, you're not working with data classes, you're working with some custom class, you can always create an extension function as well. Or in lists, we can do that in lists as well. Like for instance, we have a list of let's say 1, 2, 3, 4, 5, and we can declare it like this: A, B, C, D, E. And why it works? Because the list interface or the standard library actually, the standard library declares 5 component functions for the list type. If we add more, we are not probably going to like I think E is going to be of a different type. No? Or was it 6 actually? I don't remember. Like at some point it's going to end. That's for sure.
21
Is there,
or something. 21 of something is, if I remember correctly.
for the list? Are you
I'm
sure?
not sure.
I was checking it recently. It was either 5 or 6. But if you are not using, let's say you want to use, like the function returns 5 elements, and you want to use the first and the fifth, and then you are not interested in the second, third, and fourth, you can actually just ignore them by using the underscore. So that's a kind of a default name for the variable that you are not going to use. In the chat, is there any access level in Kotlin, like private, public, protected? There is private, there is public, there is internal, which is kind of a, I think it applies to packages or modules, but there is no protected as far as I remember. I think it's one of the most requested features as well to add to Kotlin.
The one that probably would never be added.
Yes. Well, it's not discarded. It's still on the road, not in the roadmap. It's still on the due track, and it's most highly upvoted. And there is no public official statement that is not going to be added, like about the ternary operator. So in Kotlin we don't have ternary operator, and that is probably the highest requested feature. But it's official. It's an official position that is not going to be added, and you can just use if expression. And for some people, it's a very sad story because they really want a ternary operator. But if you look at the other languages that were created in the recent decade, like Swift or Go or Rust, then ternary operator is not there. Okay, so that much about destructuring. I had the same story in the slides. And you can use this destructuring to return multiple values the same way. So like we can declare a data class and then use this data class as a return type for the function, and then assign to multiple values at the same time. In Kotlin we have a couple of classes that are in the standard library, like a pair. Let's say val p is a pair of any types. Let's say we want string, or it should be string. Let's say string and integer, and then we can say that first it will be Anton and then 16. So it works technically, but is it good for your applications? Not that much. Sometimes it's okay to use pair as a standard library class, but when you write more complex programs, you would create something more domain specific, like person, right? All right. Are there any more questions? And I see that our time is flying, and maybe I will not even get to the overview of the ecosystem, but it was a short section in my presentation anyway. All right, so there seems to be no questions right now. Destructuring, we can use destructuring in loops, right? But the nicest feature about it is that sometimes you want to iterate over associative arrays or maps, and then in Java you would have to kind of iterate over the entries and then access every entry for the key and for the value. And in Kotlin you have this map that you can just declare, I want to iterate over all the keys and values of the map, and use destructuring for that, and then you would have the direct access to the key and the value as loop variables, not to the map entry and then accessing the key and the value. we're getting to null safety. So null safety of Kotlin, I think it's the unicorn feature of Kotlin. I think it's the most important one. And if you had to kind of find a reason why to pick Kotlin over Java, I think other features are good as well, of course. But null safety is that one single feature that I would prefer, why I would prefer Kotlin over Java. So if we talk about null safety, it's kind of a feature of the type system, and therefore a feature of the compiler, where the compiler can check whether or not the value that you're working with, or like at the moment of dereferencing it, the value might be null. So you might get a null pointer exception, and that's a big problem in in the industry programs. And the thing is, null pointer exception is always a developer's fault. There is no excuse that, oh, my application got a null pointer exception, and that's because the external data that came in contained a null. No, it's your fault that you didn't check for null. But the thing is, you even if you know that some data that is coming in might be null, there is a human factor here. You might forget to check for null, and it seems like a simple problem to solve. Like, hey, just have a discipline checking for null. In practice, it has been $1 billion mistake, from the language designers to keep null as unsafe value and rely on the developers' hands and brain to check for nulls. In reality, it has been a big problem in big industry applications. So any tool that can reduce the possibility of getting a null pointer exception is very welcoming in programming language. And this feature has been added to many other languages as well now. So for instance, Dart in version 2 incorporated null safety calls into their features, and I think null safety is added to some extent added to C#. I'm not sure about Swift. Other languages have other tools for that, not this kind of null safety built into the type system, but generally it's a very similar feature where it's implemented, where we just declare a type with a question mark, indicating that this value marked with this type and a question mark might include or might be null. Alexander is saying that others have optionals, but in most cases it's a library feature. So in Java we have optional, and it's a container, right? The optional itself is a reference that might be null, and therefore it's a tool, but it's not a compiler feature. Some tools might be built on top of of this feature, of this library, to implement some static checks and verifying if it might be null or not, but it's much harder, let's say. It's much harder, and it's much harder to make it reliably, and it doesn't provide such a value as a null safety built into the compiler. So if we have this class nullable, let's say, that has a some function declared in it, and we create this other function, create nullable, that might return null, and we are indicating that by adding this question mark in the type definition in the signature, then when we are using it, like let's say we are writing the code, we are assigning some value from that create nullable function that might return null, and then we want to use this variable and invoke some function. Then if we do that directly, the compiler will see that, hey, this type might be null, this variable might be null because it's indicated that there is a question mark, and it will be a compiler error in this case, and it will enforce us to either check for null, like we would have to explicitly write, if n is not null, then we can call this function, and or use so-called safe call operator or the assertion operator. Let's see how it looks in the IDE. I hope I can copy and paste without fixing the application again or fixing the code again. Okay, yeah, it works. So there we have it. We have a nullable class. We have this create nullable function, and we can immediately see that the compiler raises a warning, exactly what we have saw in the slides. So what we can do here, we can do it like this. If n is not null, we can do this check and put the statement in here. Actually, I thought it will work here as well. Print line. Okay. If not null. Yeah, like it depends. Sometimes the data flow can tell you as well. Like if we have made all the checks within the scope here, and then if the compiler can prove that at the point where we start using this variable, n is not null anymore, then it's fine. It's fine without safe call operator like this.
There is a question in chat I think you should address.
Yep.
As long as Kotlin is used on top of Java-based frameworks and relies on so-called platform types, there is no null safety in Kotlin.
This is a very good question. I think I will explain in more details here. But let's finish with this one, and I get you this answering this question. So the other option is using this 2 exclamation marks side by side, and it's ugly enough. The authors of the language were discussing if they should use 3 exclamation marks to make it even uglier, because it should be considered as an anti-pattern. If you see such code in here, like, hey, I'm sure I'm smarter than the compiler, most likely you're not, and you will get this null pointer exception. Like if I execute, it will be a null pointer exception like this, because the value we have returned from this function is a null one, right? So there will be, so you're asking the application to throw the exception if the thing is null, but generally you shouldn't be doing it, and this should be considered as an anti-pattern. If we use the safe call operator, there will be nothing. The program will just return. So getting to the question with platform types, initially, since Java doesn't have this feature, right, of the compiler, null safety, initially the decision was to say, okay, everything that comes from Java code, when we use Kotlin and Java within the same application, everything that comes from Java code can be null. It should be nullable. It should be considered as nullable. In practice, it didn't work out, because when we started developing the applications with libraries and frameworks that we use in the industry, your Kotlin code was polluted with these question marks and exclamation marks, and that wasn't really nice, and that wasn't really practical. So it was decided to invent this platform types name and say, okay, whatever comes from Java is a platform type, but we, like, in the syntax we consider it as not nullable, but you have to be aware that whatever comes from Java might contain null. Still, you would get this null pointer exception, and that's a trade-off. That's a language design trade-off. Like, for real, if you wanted to solve this, give this like very powerful feature and be very strict about it, it would be useful, but it wouldn't be practical. So you have to balance between these two. So we ended up with the platform types. What happens in practice is that the frameworks that want to be Kotlin aware, but they are Java frameworks, like Spring, for instance, they use annotations. Let me see if I have any Java code here. Yeah, let's say I have a Java code, and they use annotations like not null or nullable, so it can be null. And these annotations are specified. There is a JSR, Java specification request for them, and there are multiple libraries. There are like different packages. I think 5, 6, 7 of those, and JetBrains annotations are part of this list. So the compiler is aware of that standard in Java. And if Java code is annotated with these annotations, for Kotlin compiler, it's an extra information about nullability. So if we say that this function here, get first name, can return a nullable value in Kotlin side, when we call this function that comes from Java code, the compiler can start doing those kind of checks for null safety, for nullability of this value. So you will get this support by the compiler. And in practice, most of the industry frameworks that want to be Kotlin aware, they start annotating their calls and their data models with those annotations to increase the user, to improve the user experience for Kotlin developers. For instance, Spring is the top, basically it's the most popular framework in Java ecosystem, and most of Kotlin developers actually using Spring with Kotlin application within Kotlin applications, and Spring annotates everything with those annotations, nullable or non-null or whatever the other annotations are there in the standard. Then to improve the usage of the frameworks or the libraries with Kotlin. So I hope I answered this exhaustively. All right, but it's not enough to give just give this option, or give this type feature in the compiler, so the compiler could check for the types. It requires a good tooling around it. By tooling, I mean the language features. So if we just added the null safety into the language, the compiler would be able to check and verify the possibility for null pointer exception, then our programs would be just polluted with null checks. Like here, this is a small example. We retrieve an order from some function, and we have to check the order itself is an object graph, right? So it has some properties. Those properties have also properties and so on, and we need to check some deeply nested properties and values within this object graph, and we would end up with something like this on the slide, where we have to check every stage, every level of those properties for null to actually retrieve the value. And this produces this kind of long checks, and this is quite verbose. Instead, by using the safe call operator, we can just shorten this very much and make it readable as well. And there are other tools like this assertion operator, which I mentioned should be an anti-pattern. We're gonna get to that as well in a second. But there is also like an Elvis operator that is looks very much like a ternary operator, but without this first alternative that you use for the check. So basically the assertion operator is the next one. So like Elvis operator, it has a name because it looks like an Elvis, this king of rock. and it basically checks the left hand side. If it's null, if the value is null on the left hand side, then it's going to execute the right hand side. So the assertion operators are created ugly by design. So you would see immediately that you have something wrong in your application, and probably you should get rid of that. But why is it happening? Like it's a small tool sometimes to overcome some obstacle and make the program work, but in reality it shouldn't exist in your application. And sometimes people start using it in places where they shouldn't. There are some better alternatives, and in most cases it happens when when some value is initialized not within the program flow, but within the life cycle of some framework. And in this case, for instance, if we use unit tests, if you write unit tests, so there is a life cycle, right? The unit tests, like the classes are read in, and then the unit test or testing framework decides, okay, this should be executed first, and then we should like initialize some values, and then we should run this test or something before the test, and then execute this test itself. And therefore, these two flows are disconnected, like the way we write the program and the way it's executed. When it's executed, we are always guaranteed to have a value, but when we write the code, we say, okay, but I don't have a value yet. It will be initialized during the runtime somehow, and therefore I will declare it as nullable and assign a value, and then I just use this assertion operator, because I'm very sure null is not going to happen, because we execute before each the setup function first, and then my field is going to have a value. It works, but it's not the best way you can do it. You can actually declare it as a late init, as a compiler feature. So late init gives me the hint, or gives the compiler the hint, that the value will be there. Don't worry, the value will be there. It will be initialized by some life cycle, and then I can declare it as a normal type, and then start relying on the compiler features for checking for the null values. So basically, that's a boundary. If we create, if we write code like where the input is a non-nullable type, like the foo function here, the test itself. So at that stage, we can rely that, okay, this value will be initialized, and further on in the application flow, when we write the code, not just in tests, maybe somewhere else, then we can rely on this compiler feature. But we have to set the boundary, and the boundary is this late init, because we rely on some external lifecycle here. Or if we are not relying on the lifecycle, then we can imagine that we are writing code that is a component within the application, where we have Kotlin and Java code, and then this, when we start interoperating with Java, then there is a boundary as well. Elvis operator, like this is why it's called like this. So you can recall, you can recognize Elvis in here. So that's why we call it like this. As I mentioned, left hand side, if it's null, then we can create some other value. The right hand side will be executed, and in practice, it's often used either to create a default value, like this. In this case here, you can see we declare a variable, we try to retrieve a person, the person might be null, and then we just create a default instance of that class. Or like we can use Elvis operator for control flow as well. Like when we check for nulls, instead of writing the if expression or if statement and checking some value for null and throwing the exception, we can just replace or even return, for instance, return statement. Whenever we check for null, we can actually use this Elvis operator like this. When we replace it, as you can see, like if you compare to the previous one, like here, it's much shorter even for this small piece of code, right? Okay. In combination with the Elvis operator, like it's quite important that how different language features play together. So there is a safe cast operator. For instance, if we are trying to make a class cast, like in Java we have this squares, right? Remember, like we let's say we receive an object as an argument, O, and then we cast it to something, and then if the cast does not succeed, we like the application will throw the class cast exception. In Kotlin, we have this as operator or as function, which works the same way. It will throw a class cast exception if the cast does not succeed. But there is also a safe cast. So with the question mark, using this with the question mark, if the class cast fails, then the operation will return null. And we already know how to work with nulls, right? We can either use the safe call operator, or use an Elvis operator and return a default value, or throw an exception, and so on. So actually, what I don't have in slides, I think I already covered classes, properties, data classes, sealed classes in a way, and even objects, but I haven't covered inline classes. And let's see what they are. Maybe while I'm typing, Alexander can tell stories about using inline classes and why they are good.
Actually, I have a lot of stories why they are not good.
Okay.
Inline classes is potentially a mighty feature, but it seldom gets overestimated, because people mostly use them for performance, and they not usually get the results they expect, because inline classes are not always inline. Current doctrine, it's not inline. It's called value classes. Actually, you should probably use the proper and the idea.
Yeah.
You should use that. It's a different, that value classes are not for performance, but for objects without identity. So you can compare them by reference.
What I wanted to tell about inline classes is that when I work, let's say I'm writing code that should use some value, and this value, let's say it's an integer in this case, and my program uses integers a lot, and but there are different use cases. Let's say there are different types, right? Value X and value Y. What Alexander said is that people are using it for performance reasons, and the reason why they are doing it is how like inline or value classes are working. Is that when I declare, let's say, X as a value class X, and then I say some integer, at the compilation time, this will be desugared, and when I look into bytecode, then the value X declaration will disappear, and basically the value will be assigned with the integer value 10. So kind of this type overhead of creating an object will be removed. And then this is why people think that if they remove this, or if they use inline classes, they will get some performance benefits. That's wishful thinking, of course, and it's not happening that much. JVM is very smart runtime. It can do a lot of optimizations, and therefore they are not getting this kind of performance boost as they are expecting. But what I like here about this feature is the ability to kind of just tell that, okay, this is not just an integer. This integer 10 has a semantics. It should be, it should be some value, but I should give it a domain name. And for instance, if I declare a function, it will take not just an integer like the n int, but instead it will I will declare it as a value X type, and then calling this function, I'm working with a real type, despite the actual operational value is 10 at the runtime. But if I do it like this, let's say I'm trying to call this function with some number, even if I know that it will be desugared, the compiler will tell me that no, you should actually provide the real type here that is declared through value x, right? And then it actually creates a real type for the type system for the compiler to check. It's very similar to let's say if we have not a value class but type alias. It's very similar at the first glance. Let's say we have value y and it's an integer, but it's just an alias. It's not the same. It will not make a compiler check. So if I'm using another declaration, let's say fun bar n, and it will be integer, then declaring a value of y and saying that it's actually a value of y, right? It's a type alias in contrast to a value class or inline class, and then I give it 10, then it's just matching the type, right? It's an alias. It's not a new type for the type system, and then I can just call bar with this y, so it matches both ways. When I'm assigning a value like this, it sees, okay, it's an integer, and the value y is an alias for integer, then it's the same as writing it like this. But if I declared it as a value x, then it wouldn't work in any way, right? Okay, so this much about the inline classes. I had to mention them because they are there, and yes, we changed it recently from inline classes to value classes, so I even forgot about this new feature. Let's go to collections. So I already showed you some of the things. The main feature of Kotlin collections, I think, is the distinction between mutable and immutable collections. So in Java, we just have everything like all in one. Basically, we don't have this distinction at compilation time. We have implementation difference. So it's possible to write that it's an immutable map, but then you can try adding some element into that immutable map. In Java, it will be a runtime exception. In Kotlin, it will not be possible to compile the code. It will be a compiler error. So whatever Kotlin does, like it seems similar, right? But in the compiler, we like in Kotlin, we have more compiler checks and therefore much safer programs as well. Like if we follow those practices. So let me demonstrate that a little bit. Let's see. So how do we work with the collections? Let's say we have a list of something. List of. We can declare it as a list of strings, and it will be a mutable one. So if I try adding list, no. Basically, it should be this operator. It doesn't compile. Why? Because oh, sorry. Or it does.
It should
I messed
work.
up something here.
It should work. It's just an extension. It's so if you write a string, it should work.
Oh. No.
Yes, it is. If you want to modify the list, you should write mutable list of.
Just a second.
This
Yes,
this one is written.
if I no, I thought it should be a compilation error
Why?
for the list of.
No, it's create a new list. It's create a new list with the added element. It's an extension for the read-only list, and it works. This one of the catches actually.
Damn. Okay, but list, how do I add? Okay, there is no add function in the list.
Yes.
That's the difference. Damn. Okay. Anyways, that's not good. That's not intuitive. It should be compilation error. But anyways, like we can do it without declaring the generic type, like either 1, 2, 3, 4, 5, right? And then there is no add function, and if it's a mutable list of, then there is add function. So I think that's the great distinction, or yeah, that the library provides different mutable and immutable types in its arsenal. Like what can you do with lists? We can iterate over the lists. Let's say iter like this by using the in operator, or we can do various operations by applying higher level functions like with map, filter, getting the first element, find something, find elements. Let's say it should be if elements, find all elements greater than 3, should be 4 and 5. Result, and then let's say we are printing out this result. It takes, I don't know, I didn't compile this project before, I think. Sorry, I think I've messed up something. All right, I will not try to fix it right now. Plus method. There is a question. What about the plus method? This is exactly what Alexander said, that if I use this list of, and then I use plus 12.
You just can control click on plus and see what it does.
Yeah, it will be plus collections, right? Okay. So I think I have spent so much time on the basics. We should move into some more interesting stuff. Like, okay, Java interoperability, we have mentioned that before. You can actually call Java from Kotlin and Kotlin from Java. Calling Java from Kotlin is not a big trickery. It's usually, you just use it as a class. It gets trickier when you want to call Kotlin from Java, because first of all, you have to know what is the class name. The compiler adds, where was it? As you can see, was it here? Okay, it wasn't here. But anyways, like the compiler derives the class name when we don't have it specified from the file name. So in this case, if we have main.kt and we just have functions here, and we want to call those functions from Java code, in that case, the compiler actually generates the name called main.kt, and then we should be able to. Why is it not seeing it? Maybe because I don't have a package name or what? Package com JetBrains learn Kotlin, and then I add file, let's say main.kt like this, something is wrong. Let's see. Maybe it requires compilation. Duplicate name.
I actually can't see the problem. It should work. Not sure why it does not. Probably.
Maybe because I have an EAP early access version of the new plugin. Maybe that's why.
Yeah, something with an idea here. It should work.
Strange. I think it's the compiler problem, not compiler problem, but the plugin problem. I have a very early access of the recent version. I was testing it, but generally it should look like this: main KT, and then I am able to access whatever function I have declared here, like fun, foo, and then oh, now it started to seeing it. Interesting. Okay, so you have to be aware of this naming, plus some of the things that we have seen in the previous slides, something like default arguments, for instance, as string with the default one. From Java, it should be visible. Like the expectation might be that you will see both functions, foo with no argument and foo with argument. But by default, the compiler will generate such code that the Java side will not see the function with no argument, and you will have to supply one. Otherwise, you can help the JVM overloads by using the some annotations like JVM overloads, JVM field, to generate bytecode that is kind of compatible with Java, so the Java code would see proper declarations or whatever Java compiler is expecting at that point. So JVM overloads annotation will help here, and in some class in this code we should be able to see both both variants of this function with the parameter and without parameter, like this. So there is like there are some corner cases where like some very specific Java features are not reflected in Kotlin one-to-one, and then you have to use some workarounds. But generally, calling Java from Kotlin is 99% compatible, and vice versa, calling Kotlin code from Java, sometimes you have to help the compiler by annotating, by using the annotations. Basically, you express this desire that, hey, my code will be used, my Kotlin code will be used from Java application, and therefore you need to generate something extra. Okay, how much time do we have? Like half an hour. Standard library is pretty good in Kotlin, but in most cases it adds some extension functions to the existing Java classes, and of course it provides some of its own types. But if you want to learn about it more, like what kind of functions are there, so it's not part of the language, it's part of the standard library, and therefore I decided not to include too much information about it. We have seen some of the features already, but you can learn about it on our YouTube channel. We have, if you go to youtube.com/Kotlin, me and my colleagues are producing videos there on various topics, and you can see, you can find a playlist called Standard Library, Kotlin Standard Library Safari, made by my colleague Sebastian Eigner. Those are awesome videos, very entertaining. You know, you can see the demos of different standard library features there. We have some other things like idiomatic Kotlin, how to write idiomatic code, and we are going to get, I think like half an hour is enough to actually show you some idiomatic use of the features that we have mentioned in the previous slides. And we have some practical demonstrations of Kotlin for various domains. And specifically, I'm involved with the webinar series about server-side, where we use Kotlin for various server-side projects developing web applications. I'm going to skip through. I'm going to skip this example here and go into more practical, let's say, use of it. This example is basically a challenge from the Advent of Code from the last year, like from December. If you don't know about Advent of Code, this is like an entertaining challenge every day since December 1st. Someone publishing the challenge that you can solve in different languages, whatever language you prefer. Your goal is just to solve and automate the problem and get the correct answer, basically a number of some kind, and then submit this number and verify if your number is correct or not for the provided input. So we have been publishing a few episodes from 2020, I think. Yes, from 2020, implementing those challenges in Kotlin in a idiomatic way, like how you can nicely implement some of the constructs that you want to use for the specific task. So I wanted to include this here, but since like the time is running up, then I decided I think I'm going to skip. What I want to talk a little bit more is the idiomatic notion of Kotlin. So like idiomatic is not a strict rule. Basically, when we talk about idiomatic something, especially applied to a programming language, it means that we are following some sort of a commonly accepted style. Like either the style is dictated by the vendor of the language, or maybe by the community. The community develops the rules. How should we be using some of the language features, for instance? And there are different like usually those recipes, those small recipes for the problems that we want to solve with those idioms, with those small constructs, are following some either best practices, or they promote like effective use of the language features with a special goal in mind. Either it's readability or performance. You want to get more performant code in that place, or just it's almost like design patterns, if you're familiar with that, but for smaller pieces of code. So we are actually collecting that in the documentation, and if you go to the documentation, you can find this page, and the page basically explains you, okay, if you want to do this, you can write this code like this, right? Small snippets of code, and we are working on creating more pages, more recipes in the documentation for the same purpose. Like especially if you're a Java developer, it will be useful. For instance, if you want to read a file, right? You know how to do that in Java. Here is the example, and then you can, see how it's done in Kotlin. You want to iterate over the collection. This is how it's done in Java. This is how it's done in Kotlin, and we will have we already have some of that in the documentation as well. So, but where Kotlin really shines is like by applying language features in an idiomatic manner, is creation of domain-specific languages. I think it's actually not fair to call them languages, because it's just the idiomatic views of language features that are provided by the host language, in this case Kotlin. And let's make some theory here. Like if we talk about DSLs, or if you read somewhere about DSLs, they usually refer to them as external DSLs, external domain-specific languages, and internal domain-specific languages. For both the use case, both of them have their own use cases, own applicability, and own approach for designing this kind of tools. For instance, at JetBrains, we have a project called MPS, meta programming system, that is tailored for creating and designing external domain-specific languages. And since domain-specific languages are not that common in practice, it's not like a generally general purpose languages that you use in the editor. You get this auto-completion and so on. So it makes sense to build specific, like tailored tooling for using those languages. For instance, in MPS, it looks very much like the normal editor in IntelliJ, but it's not really a text editor. It's a projectional editor. So it gets a domain-specific model and generates the editor. So that the user of this language would not be able to make any mistakes when using this language. So with external programming, like external DSLs, you have to create your own parser, your own analyzer, your own generator, code generator, and tooling around it. And with the internal DSLs, you are limited with the expressiveness of the host programming language. In this case, it's Kotlin. And I'm going to give you a few examples of the DSL-ish constructs that you can meet when you are using Kotlin in your applications. For instance, in Java, we have this string builder to generate strings. And when we use string concatenations in Java, we actually the compiler actually desugars it to string builder invocations. In Kotlin, we have some functions in the standard library that create kind of a wrapper around calls to the string builder. And by doing this, with all the syntax sugar that Kotlin has, we're able to kind of use it in a more declarative manner, right? If you compare these two, they do exactly the same, but it's much clearer on the right-hand side, right? And for instance, there's library for generating HTML documents, which is type safe. It's built with functions, extension functions. Instead of creating the file like the HTML in the text or in a string, we can use the functions with the help of the compiler and generate those documents. Some people like it. I think it's a nice library, but it demonstrates, first and foremost, it demonstrates the power of the language features in Kotlin. Another example, using Ktor, which is a web framework, in combination with Kotlin XHTML library. So in Ktor, we have this DSL for declaring routes in the application, so the endpoints. And we can intermix it with the Kotlin XHTML library. Those are different DSLs, but it actually can be used, both invocations can be used in the same file, because it's not a different language. Those are not different languages. This is the same language. Kotlin is just that we use it in a idiomatic way. So they all look similar when we start looking and analyzing them, and they are similar in this way. Usually it's some sort of a function call, and like we follow like further, we create the structure. We can do assignments within those calls. We can return values from the functions. We can use some syntax sugar, and it will all be syntax highlighted and compiler checked, right? And it's nice. It has a structure and it's readable, and it looks like a declaration of some structure. It feels like it's not imperative. It feels like it's declarative. And I actually wanted to show you a demo. I think I can manage in 15 minutes. There is a question: can we build 3D website with Kotlin using Ktor? I'm not sure what the question actually means. Ktor is a server-side framework, so it can receive HTTP requests and send responses. So about DSL, like what kind of example I wanted to show you. I have some Java code. Let me show you that. So where I build a model, a class object model, object graph, by using a few classes like client, company, and then Twitter, Those are just getters and setters and fields. And then we have builder pattern implementation for those classes. And this is the example code, how it looks in practice when we start using it. So there's nothing wrong with it. You just have to read through this lines of code and understand what they are doing. It's easy to understand. But let's try to do some transformations with it and see how it transforms and see how it's different. So if we go to Kotlin and try copying this Java code from Java file to a Kotlin file, the IDE will actually detect that we are now copying some Java code from somewhere and into Kotlin file, and it will suggest to convert it automatically. And yes, by clicking yes, it will do the transformation. And we can see the first set of transformations done here. There is no new keyword. In Java, we have this new explicit keyword. This is a similarity with Python, where we decided to get rid of this new keyword for constructor invocation and just follow the notation that whatever is written with a capital letter must be a constructor, but it's not a strict notation. It's not compiler checked, so you can do whatever you want. Then there is an optional semicolon in Kotlin. The IDE actually makes it gray and says that you can remove it. So when we were transforming the code, it removed the semicolons. There is no getters and setters. Instead, we have property access. So instead of invoking set first name, it transformed into just first name. But in fact, it desugars to property to setter invocation. So if I navigate, you can see that it navigates to a setter. What else? We have also those templates. So in Java, we would have to use plus for the strings. In Kotlin, we can use templates, and even the IDE actually helps me with that. So converting the concatenation into a template. So what could be done for transforming it is basically, since we are creating something, usually the entry point would be something like create client, something like this, and we can follow that notation. For instance, we would have a function called create client that returns client, but it needs to execute some sort of a block of code. Let me see, like this. And the block of code in Java, it would be usually like something like an interface with one function. In Kotlin, the alternative is to use just a lambda. For instance, block. And this lambda would take a builder as a parameter. Let's say like this, client builder, and the lambda itself doesn't need to return anything. We just need to return something from the client, right? So the lambda can be just executed, and they are going to get the final result inside the instance of the builder. So how do we execute it? We can execute this block like this, and yeah. Can I? One second, there is a question. What about garbage collector in Kotlin? Kotlin uses JVM garbage collection, so there is no like specific garbage collector by Kotlin for the JVM. In Kotlin native, there is an implementation for that. So let me actually simplify this a little bit. What I wanted to do. So the block can be invoked, and then I need to supply an instance of the client builder, right? So val builder, client builder, and then supply it here. And the result will be inside the builder. So we're going to return the result after the invocation. Builder build. That's going to be the instance of client that we just built. So how do we use this function? Create client. In fact, the invocation is automatically generated here because I used auto-completion, but what is happening is I'm calling a function with a lambda as a parameter. And in Kotlin, if lambda is a last parameter in the call, then we can just amend the braces around it and use it like this as a block. As you can see, there is an implicit variable called it. The ID hints us about that, but we can explicitly write out this variable or even say that it should be a builder. And in fact, now we can just move this block of code here into the function call. And instead of calling the builder build on the top level, it's happening now within the function, right? So we are passing in this block of code right here. It's going to be executed where we provide the builder, as a parameter, and then the result will be inside the builder, and we are returning it, and that's the client. So what is nice here is that we already created a structure. It was the first step, but as I said, for instance, we can make it even shorter and try transforming this code further by minimizing the number of characters that we type. For instance, if we use it as an implicit variable like this, right, we don't have to specify it, remove arrow, and it's already less characters, but it feels a little bit inconvenient that I have to type it all the time. So what if I wanted to access first name directly within the block? And it's also possible. But we just have to make this instead of it, right? And this variable should be of type client builder. How can we do that? We need to declare this block of code as something, as lambda, that should execute within the scope of client builder class. And we can do that in the declaration. Remember about extension functions. When we declared a new extension function for the type, everything that was in the body of that function referred to the class that we are declaring this function for. So if we had something like fun client foo, then within the body of this function, we would have access to the first name, right? Because we are creating the extension for that class client. So if we wanted to get access to the first name of the builder, we have to declare this lambda as an extension to client builder, and we can do it like this. We can move it out and declare that this lambda is an extension. So this is a type, right? And this is an extension. By using this dot, we say that, okay, this block of code is an extension to the client builder. And then we can just remove this it from here, because now we are in the context of the client builder, this whole block. And we already have the first name and last name access. We can do the same for Twitter builder and for the company builder, and finally get to the point where it all will look like this. It will look something like this. Handle, and then company, and then remove Okay. I made a mistake like this. So after a few transformations, we can get to the point where the final code will look like this. I don't have time to actually type it out for you, but I have a final example right here. Let me show it to you. You can find this code in GitHub as well. Let me see. Client. Probably missing some curly braces here. Yeah, like this. So it will look like this, right? We have some sort of a document almost. Like if you look at the structure, it looks like a document where we just declare the object graph by using those idioms from the language, and those are the extension function, the lambda with extension, where we can declare that some block of code should be executed within a context of the specific object. Then we have property access. We have trailing lambda with that doesn't require braces, and this all small features result in this kind of clear structure. If we compare to the initial code, let's say example, no, split right, and we gonna check what was the initial code when we started with that. So if you compare the code on the left and the code on the right, like this, it doesn't seem that we have won a lot of lines of code, but we definitely won in characters. And plus, on the right hand side, like in the Java version, it feels like it's just a wall of text, right? We have to read through it. On the left hand side, we have a structure that we can follow with eyes and read faster. I think this is a great like benefit of this approach, but be careful. Like nothing comes for free. You're going to add some complexity with some interesting language constructs if you're doing this. And so you have to know, like you have to acknowledge that you're adding some complexity to the project by using those language features. Maybe your colleagues are not familiar with those concepts, so it's a kind of a trade-off, and it makes sense if you are doing this, if you can reuse this code in various parts of your applications, or extracting it as a library and then reusing it in various projects. I will provide the slides with all the links, and I will recolor them into one theme and send to the organizers, so you can check it out later. With that, I think our time is up. I hope it was entertaining enough and you have learned something. If you can provide me the feedback, I will be happy to read it. I didn't cover all the things that I wanted initially, but I think it was okay. I hope it was okay. Thank you, Alexander, for helping me. I'm really out of voice already, and I hope it will be interesting for you in the next lectures.